Hey everyone, so welcome back to my Devlog channel, and in this video I'm gonna take you through the process of implementing an enemy class in SFML and C++. As you know, creating an enemy class is a crucial part of many game development projects, so I'm very excited to share my approach with you. I'll be covering the key elements of the class, including its properties, methods, and behaviors. So before we dive in, I just also have a quick announcement, and that is that I'm gonna start streaming here live on YouTube every Tuesday and Friday at 5 p.m. CET time. So don't forget to subscribe and also don't forget to, sometimes pop in and say hi. I already know some of the topics I want to cover on my streaming, and I forgot to mention I will most likely be programming during those streams, and I will be developing this game. Alright, now that that is out of the way, let's start. So I guess we can start with the enemy class itself, what I kind of did. So I created a enum which will contain all of the different enemy types. And just to mention, I haven't implemented all of the enemies. As you can see, there is just one like normal enemy. In this video I just want to cover kind of all of the enemy class. And I guess we can actually start, and you can see some of the behaviors that the enemy can do. So as you can see, it follows me, and it can also shoot when it reaches a specific point. I can also shoot back, and as you can see, I'm already dead, but whatever. And I can shoot, and after a while, okay, I gave it a bit of a higher, there we go, I gave it a bit of a higher health for debugging purposes, and that's kind of what I did. So I can take it through some of the variables. So this is obviously the main shape that contains the enemy. Then I also have a weapon, which I'm pretty sure I already made a devlog on this, right? Then it also has a health and a speed. It needs to also hold a pointer to the player so that it knows which position to follow. And then this is kind of like the stop following functionality. I also added it as a shape so you can see that we can also draw, and I can just show you quickly what it can do. So see, this is kind of the boundary of where it will start shoot. So yeah, that's what that does. And yeah, this is for some testing purposes. This isn't gonna be in the main in the finished product, and yeah, this is just the player position which we can get from the player entity. Now the constructor, obviously it's going to take in a type, the player, and the position, and then the window and index we pass it along to the entity base class. Then we also have a fixed update, the normal update, and the render functions, and also the take damage and get health. So in our constructor there isn't anything too special. We just set the tag equal to the enemy, and then yeah, check which type it is, and then set the necessary properties depending on which type it is. So for example, I might have some other enemy that its speed is going to be higher, or their health will be a lot more, and they might even have different weapons. As you can see here, we are creating that weapon. And then this is for the stop following shape that I showed you before. And now here in the fixed update, this is where we actually gonna follow the player if it's inside the boundaries. So what I did is I got the player position here, and then I normalized it so that the enemy knows which direction to go. This does provide a problem. If I can just I can show you what it kind of does. Oh yeah, no, it actually works. As you can see, it can start flying, even because like the direction is technically up there when I'm jumping. So that's why we kind of have to set the y direction equal to 0, right? And yeah, so if we are inside the if we're not inside the boundaries of the stop following shape, then we can start moving and also move the weapon with us. Otherwise, we can start shooting. And yeah, we also have to rotate the weapon so that it rotates towards the player position. And so to take damage, it's very, very simple. We can just check is health minus the amount gonna be less than 0? If it will be, well, then we know that our enemy is dead, and we can remove our enemy with our game manager. Jesus Christ. Okay, now in the game manager, this is where it kind of gets, messed up. I mean, not messed up, but there's a lot of stuff to cover. So yeah, we simply create our enemy class and push it in a vector. And this is where I kind of saw an issue, because if you have been watching my devlogs for some time now, you might know that the entity class is where I want all of my things to be in. But I can't have it like that, so now I have to separate them into 4 vectors, which is annoying, right? And I can show you exactly why. So in this part, I'm checking for bullets colliding with enemies or the player. So I loop through all of the bullets, I loop through all of the enemies, and if if they intersect, well, then we can erase the bullet and so on. But how I had it how I wanted to have it is I wanted to just loop through all of the entities, obviously twice, but then if they intersect, how do I take the damage from our enemy, or how do I get the damage amount from my bullet? See, that's kind of the issue. How do I get a derived class from the base class? And this meant that I have to split them into like 4 of them, which, yeah, is annoying. And also, before you write down in the comments, I do know that this is a very bad way of checking for collisions, and this actually brings me on to my next thing, which I wanted to talk about, is the thing I'm going to be streaming today. Let me just take a sip of my coffee. Hold on. Very good coffee. Okay, so today I want to implement the quad tree. Okay, I hope I can just yeah, here it is. This is what I want to implement. So for the actual collisions, which if this works, it will save me so many frames, right? Because how I'm doing, if anyone knows with the big O notation, I have it x squared, which means that, okay, if there are 10 bullets and there are 10 enemies, well, then every bullet has to check for every enemy. So that's going to be 100 checks. And that might not be that slow. I mean, computers are designed to, make, sorry about that, make a lot of checks every second. But if we have 1,000 bullets and let's say 500 okay, not 500, that's a bit too much, but like 100 enemies, well, now it starts to get like a really many checks, and I'm planning to have a lot of bullets. And as I read it, it seems like quad tree is actually big O log n, right? If there is anywhere that I saw it. Oh, there we go. It's usually operating in O log n. So this means that I can just, let's do some math, right? If we have 1000 bullets, for example, and let's say, I don't know, 20 enemies. Oh, okay, there we go. This means that I only have to, okay, check 5 times, which is, hell yeah, that is much better than 20,000 times. So if I can implement the quad tree today, that would be awesome, because I can actually, yeah, because how I'm doing it right now, I don't really have to do it because I'm erasing the bullets every time they hit something. So it's very unlikely that there's gonna be like, I don't know, 20,000 bullets, but it's still, I still think it's very good to implement the functionality. So yeah, that's just what I'm gonna do today. But yeah, I had to split the vectors, and this meant that I had to, do this for the render function and do this for all of the adding stuff. But yeah, that's just how I had to do it. And then I also forgot to mention the remove enemy. Well, I simply delete the enemy object, which has the same index as our parameter here. And then I also have to delete the weapon object with the same parameter that is here. And that is basically how I got my enemy class to, I mean, sort of work. Yeah, there was a bit of troubles, but yeah. I'm also planning to, but that's later on, I want to add like a UI on top of the enemy and the player, so that you can see how much health you have. So thank you so much for making it this far. Like, again, I'm gonna be streaming today, so if you want to say hi, don't forget to subscribe, like, and so on, and see ya.